Okay, today we're going to look at section 4. This is the last lesson in this portion of our chapter for us. So that means today we'll have this lesson. Monday we'll review what we've learned this week, and Tuesday you'll have a quiz on this stuff, and that will be your last quiz that goes on to the first semester grade. And then we'll have a couple more homework assignments to finish out the week next week. Chapter 8 has been about right triangles, and in this first part we've been learning some properties of right triangles. In the last 3 sections of Chapter 8 that we'll talk about next week, we're going to introduce an idea applied to right triangles called trigonometry. Then after that, we're going to do some more trig, but not from our textbook, because our textbook only kind of introduces the idea and doesn't do very much with it. And according to state standards and expectations for what you should know, we need to have a little bit more broad of a background on trigonometry before we move on. So the reason why I'm telling you that is because today's lesson is extremely important to the study of trigonometry. Like, I cannot overstate how important it is that you get this to be able to study trig. This is a really big deal in trig. Today we're talking about 2 special right triangles. They are called our 30-60-90 and 45-45-90 triangles. We're not extremely creative in naming things in math. They're named that because that's how big the angles in them are. So our first theorem tells us if we have a triangle that has angles that have measures of 45, 45, and 90, says then the hypotenuse is, and it's missing on mine, but I think it's there on yours, square root of 2 times as long as a leg. So the legs are the perpendicular pieces. And because both of the angles in this are 45, that means this is an isosceles triangle, and both of those legs are going to be the same size. This theorem tells us the hypotenuse is that length times the square root of 2. Our 30, 60, 90 triangle has angles of 30, 60, and 90. Says the hypotenuse is twice as long as the shorter leg, and the longer leg is, and again my symbol is missing, square root of 3 times as long as the shorter leg. So we'll have a triangle that has angles of 30, 60, and 90. We're going to base everything off of the shorter leg. The shorter leg should be across from the smallest angle. So what we're going to look for is that 30-degree angle, and across from that, we're going to call that side X, and we're going to base everything off of that shortest leg. That's going to be a key to finding that side first in our problems. Then the theorem tells us the hypotenuse is twice as long as that, so that's going to be 2x. And the longer leg is square root of 3 times as long as that. So that side is going to be x square root of 3. So memorizing these 2 patterns is going to be really important, not just for this lesson and for Tuesday's quiz, but for the next several weeks as we're studying this idea of trigonometry. These triangles are very important in trigonometry. So we'll do some examples. So for our first problem, we have a triangle that has a couple of 45s in it. Now we weren't told all 3 angles, but we know the 3 angles of a triangle have to be 180, so if we've got 2 45s, we must also have a 90. Our 45, 45, 90 pattern says the 2 legs will be the same size because it's isosceles. So that means y is going to have to be 6. And the theorem tells us that the pattern is that the hypotenuse is square root of 2 times as long as a leg. So we'll say 6 square root of 2 to do that multiplication. We just write it right after it. We can't multiply together when one number's out and one number's in. Okay? If they're both under square roots, you can do it. If they're both not under square roots, you can do it. But if one's out and one's in, we just write them right next to each other. 6 square root of 2. Here we're told we've got a 90 and a 45. The other one has to be 45 because that's what would finish out our triangle. So we have this 45, 45, 90 pattern then. Our pattern in our 45, 45, 90 is that the two legs are the same size. So x and y will be the same, but we don't know what either one of them are. We know the hypotenuse is square root of 2 times as long. So if I'm trying to work my way back from the hypotenuse, how do I undo times? Division. So if I divide 10 square root of 2 by a square root of 2, I get 10. We have another 45, 45, 90. So x and y are going to be the same because they are the legs. And we're given the hypotenuse. So like the last problem, to work our way back from the hypotenuse to a leg, we need to undo timesing by the square root of 2, and we undo timesing by dividing. In the last problem, it worked out nicely because there was a square root of 2 to divide out of it. Here there is not. So we're going to have to do a little work on this one and do 12 divided by the square root of 2. We learned on Monday that we're not supposed to leave square roots on the bottom. So how do we fix them? Multiply by them. We have to multiply by the same thing on top and bottom, so we're really only multiplying by 1. On the top, that gives us 12 square roots of 2. On the bottom, it gives us just 2. That's why we multiply by it, so it cancels out, and we just get that number. Then the numbers outside can reduce to give 6 square root of 2 as our answer. And both x and y are going to be the same because it's isosceles. Questions on the 45, 45, 90 pattern? Okay, then we're going to look at the 30, 60, 90 pattern. In the 30, 60, 90 pattern, you're going to want to locate your short leg first, which is always going to be across from the smallest angle, which is the 30. So the 30 is up top here, and the short leg then is the 5. Everything in the 30, 60, 90 pattern is based off of that short leg. So you want to locate that first. Then our 30, 60, 90 pattern says that the hypotenuse is twice as long as the short leg. So how big will the hypotenuse be? 10. And is that x or y? X. So x is going to be 10. And our 30, 60, 90 pattern says that the longer leg is square root of 3 times as long as the shorter leg. So that's going to be 5 square root of 3. So we have a 30, 60, 90. In a 30, 60, 90, we want to start by locating our short leg. Across from the smallest angle, across from the 30, it's x. We don't know what it is. That means that's going to be the first thing we want to find because everything's based off of that. So we want to know what that is first to build from it. We know our hypotenuse. What is the relationship between the short leg and the hypotenuse? The hypotenuse is 2 times the short leg. So if I know the hypotenuse and I want to get back to the short leg, what do I need to do? Divide by 2. So x is either going to be 13 over 2, or we can say it's 6.5 since it divides pretty nicely. And then from the short leg to the longer leg, our theorem says that it is times the square root of 3. So it'd be 6.5 times square root of 3.
can stop it there, right?
Yeah, yep, there's nothing more to do to that. Alright, so we want to start by locating our shortest leg, which is going to be across from our smallest angle, the 30. So that's going to be x. We don't know it, that means we want to find it first so that we can build from it. Do we know the hypotenuse or the longer leg?
Longer leg.
Longer leg. What's the relationship between the longer leg and the shorter leg?
X
Times the square root of 3. So if I multiply to get from the short to the long, but in this problem I want to get from the long to the short, what do I need to do? Divide. So we need to divide by the square root of 3. We're not allowed to leave a square root on the bottom, so we need to multiply it on both top and bottom. That gives us 9 square root of 3 over 3, which we can reduce out the front of that to get 3 square root of 3. So that's our shorter leg. Then we need our hypotenuse. What's the relationship between short leg and hypotenuse?
Short leg is half.
The short leg is half of the hypotenuse, or we double to get to the hypotenuse. Now when you double 3 square root of 3, you only double the front number, because what we're doing is 2 times 3 square root of 3. So we're going to multiply together those outsides, but the square root doesn't change. And a lot of students would want to write something like 6 square root of 6. Right? We're only multiplying the 2 by what's outside. We can multiply outside stuff together.
How would you add those together?
Would you add them?
Mm-hmm.
Add what?
The 2 and 3 square root.
You can't, actually. Yeah, there's no way to combine them with addition. Questions on the 30, 60, 90 pattern? All right, 3 more examples where we're given a little bit more than just a triangle. All right, and this one we're given a square. All 4 sides are the same, and we have a right angle, so we know that's a square. We want to find what one of the sides of this square is. Is that triangle going to be a 30, 60, 90 or a 45, 45, 90?
45, 45.
How can we tell?
Because they bisect.
Okay, the lines on the bisect the angles, or because 2 sides are the same, means 2 angles have to be the same. Those are going to be semi-isosceles triangles. So we're going to use our 45, 45, 90 pattern to get from the hypotenuse back to a leg. So what do we do?
Divide.
Divide 8 by square root of 2. For our 45, 45, 90 pattern, the hypotenuse is square root of 2 times as long as a leg. So to get back from it, we divide by square root of 2. Clean up the bottom by multiplying by square root of 2. On the top, that gives 8 square root of 2 over 2. In the bottom, just a 2, which we can reduce out to get 4 square root of 2.
All the way around itself?
All the way around, that's what all 4 sides are. We aren't told what kind of triangles these are, and we don't want to make any assumptions about what kind of triangles they are or how they look. If we look at the entire big triangle, ignore that middle line, what kind of a triangle is that?
Equilateral.
It's equilateral because that bottom is 2 tenths, which is a 20, and the other sides are 20. So all the sides are 20, which means all the angles are equal. So they are all 60. So this angle will be 60, this angle will be 60, the top angle will be 60, and it's going to be split up equally because that bottom side was split up equally. So then now we can see that we have a 30, 60, 90 pattern to work with here. So in a 30, 60, 90, we want to locate the short side of the triangle. What's the short side going to be?
The bottom.
The bottom, the 10, because across from the 30 gives us our short side, which is 10. And we're looking for the longer leg. What's the relationship between the short leg and the long leg? What's the relationship between the shorter leg and the longer leg?
10 times the square root.
Times the square root of 3. So 10 times the square root of 3.
So for these, we're never going to need to like simplify the square roots.
Nope, what's inside of the root you won't have to. And for our last example, we will combine the two triangles. So I want to start where I have information, where I have numbers and not unknowns. So I'm going to start up at the top here, where I know a 9 square root of 3. That is a 30, 60, 90. We want to locate the short side. We don't know what that is. Okay, across from the 30 is a blank. We know the longer leg. How do I get from the longer leg to the shorter leg of a 30, 60, 90? The longer leg is square root of 3 times as long. So what's the shorter leg going to be?
3 times square root.
27
9.
square.
Yes!
We're dividing out a square root of 3. And it has a square root of 3 to divide out of it, so we just get the 9. So we go from long leg to short leg, we divide out a square root of 3. So we get 9 there. What is the relationship between the short leg and the hypotenuse in the 30, 60, 90?
Hypotenuse is twice the length.
Hypotenuse is twice as big, so that means our hypotenuse is going to be 18. So far, we have found 2 answers that we weren't asked for. So now we want to try to find an answer that we're asked for. In the lower triangle now, we have a 45, 45, 90. That 18 is in both of the triangles. So now we know the hypotenuse of a 45, 45, 90, and we want to get back to a side. How do I get from hypotenuse to a side in 45, 45, 90?
Square root 2 times 18.
Divide by the square root of 2. So our rule is that the hypotenuse is square root of 2 times as long. So to get back from the hypotenuse, we need to divide out that square root of 2. Multiply top and bottom by square root of 2. There's 18 square root of 2 over 2. Reduce out gives 9 square roots of 2. Okay. Your assignment tonight is from 8.4.